Well, good morning, everybody. Welcome to physics this morning. It's been a long weekend, but I think you can remember some of the things that we did last week. To review just a little bit, we did the soccer punt. And the one thing that we're going to change about the soccer punt is it's not going to start and stop on the same x plane defined by a y coordinate. But just to kind of review what we did here in the beginning, it's this whole symmetry thing that you have to really understand to get a lot of these things done. So one of the things we set up here in v there is 0 in the y direction. But in the x direction, the v is constant throughout. So no matter what part of the projectile motion or the trajectory we're in, these vx's are all equal to each other, although this one's a little long, but these are all equal to each other. Because free fall definition is the only force on the ball is gravity, and gravity is in that direction, and no part of it is in the x direction. And the x and y stuff are independent of each other. You have to keep that in mind. The other thing that we said is, as we go higher and higher in this way, we get down to a v in the y direction that decreases in magnitude until it hits here, and right there we said it's 0. And then it starts to increase in the negative direction like that. And we also said that if we go to a specific point on that would be on the same x plane, then we're going to have the same velocity, magnitude, but different direction in this case because the y changed. But the change of the y was equal on the way up to the way down, just opposite in direction. But there's this like symmetry that happens in all this stuff. The way up is equal to the way down as far as time. So if we're doing this, our time to get to the high point is going to be equal to half of the total time. And then the other half takes us that way. And a lot of times we use half of this time to figure out what our initial y velocity was, because we could use the fact that the y is 0, and we could go v equals v sum naught plus at, and we could cancel this out because we know it's 0. Or we could have canceled this one out and left the final velocity a number, pretending that we drop it or using that half of the equation. So all those things we already did. And hopefully you're getting a grasp on that. But today we're going to talk about something a little different. Today we're going to talk about what happens when the soccer punt goes off the edge of a cliff. Because no longer does half the time take you to the top. And that's not half the time anymore. That'd be less than half the time in this case. Or if I was going down here, up, that would be more than half the time. So we can't do it like that anymore. But all the same rules apply. We're still only using the first 3 equations that we talked about, and all the same rules apply. So I'm just going to give you a couple examples of how we would do something like this. And then I'll let you give it a try. Well, let's just say that we have a cliff that's that high, and we'll say that we have an angle here. Well, let's say we don't know the angle. Let's say that the total time that it takes to do this is 4 seconds. And let's say that we have a displacement in the x direction. So in other words, our trajectory is going to land us over here. And we'll say that we know this displacement here is 10 meters. Okay? So now we have to figure out what the velocity actually is. And that's going to include an angle. Because if I say velocity or acceleration or any vector, then you should be thinking, I need an angle for a direction. Unless that's given to you. Well, does anyone see what we know right away? Yeah, the displacement we know, and we know the time. So the velocity in the x direction is equal to the displacement in the x divided by the time. Velocity in the x direction is 10 divided by 4 is 2.5 meters per second. Any questions on that? Okay, so then I'm just going to chalk this in right here. So I know part of my triangle is 2.5. Okay, so now I got to deal with the y stuff. Okay. So we have velocity, so not in the y, equal to, we're not sure. Velocity final in the y, we're not sure. Acceleration we know is negative 10. Displacement has to be negative 4 then, right? That's what would trip people up. But remember, displacement is from beginning to end, straight line, with direction. So in this case, I already said acceleration is negative 10, so the displacement has to be negative because it's in the same direction. So we can just use our kinematic equations for that, and we can say x equals v sub naught t plus 1/2 at squared. And then we can fill in the numbers if you want at this point, or we can solve for v sub naught, whatever you want to do. X minus 0.5 at squared divided by t equals v sub naught in the y direction. Do you agree with that? Algebra? Okay, I didn't really leave myself quite enough room here. I'm going to have to take this over here for the algebra. But starting with the x, that is then a negative 4, because it's going down, right? And then we have a minus, and it's 0.5 times a negative 10, because that acceleration is down. And then our t, which I just erased, was 4 seconds. So you square that and you have a 16. Okay, and you divide that by 4, and then that will equal our v sub naught in the y direction. So if we plug and chug, our number should show us that it's 19 meters per second. Notice it comes out as a positive number. That's because we didn't mess with anything. We just did it flat out the way it was. We used the displacement in the right direction, the acceleration in the same direction, and they were both negative, downward. So this is indicating that it's upwards. So now we have 19 meters per second, and then we just do a squared plus b squared equals c squared to get our velocity. Did anyone happen to do that? And then the inverse tangent of 19 over 2.5, and we should have our final answer. 19.16 at 82.50 degrees above the horizon. Okay, should we do another one? Okay, let's say that we have launch at 30 degrees, and we have a displacement here of 15. And we have a time here of 7 seconds. The question is, how far in the x direction do we go? Any ideas? Okay, so we have to make the y list first. You don't always make the x list because there's not as much stuff, but the velocity, so not the y direction, is really what we're looking for. We don't have the final velocity in the y direction. We do have little g is negative 10. We do have displacement is negative 15 in the y direction. And we do have time is 7. So using that same formula, I think we can figure out the velocity in the y direction. So then x equals v sub naught t plus 1/2 at squared. This time I'll just fill in the numbers first. Negative 15 equals what I'm looking for times 7 plus a negative 5 times 49. Okay, so if I solve, well, if I take negative 15 minus actually, we have to add 245 here, so it's negative 15 plus 245, and then we're going to divide by 7 to get our v sub naught in the y direction. So negative 15 plus 245, 230 divided by 7 would be 32.86. Notice it's a positive number, so that means that we have a positive y velocity, as long as we haven't messed anything up. So 32.86 is right here. 32.86. Well, we should be able to now figure out what the x velocity is just because we have the triangle, right? So the tangent of 30 is equal to 32.86 over the velocity in the x direction. And in order to solve for that, we have to get that out of the denominator, right? So the velocity in the x direction then is 32.86 divided by the tangent of 30. Our velocity in the x direction is 56.92 meters per second. So now we can figure out our velocity here now, right? Because a squared plus b squared equals c squared. I'm not going to show that math. My displacement here then is my velocity in the x direction times the time. In this case is 56.92 times 7, and that's equal to 394? 396, something like that. 398.4 meters. And that's how we do that. Let's do another one. Okay, let's do another one here. This time I'm trying to figure out again how far in the x direction I'm going to land, which kind of brings us back to our lab and the projectile shooter. Okay, so we did have velocity out of the projectile shooter, and I did give you an angle. So this is really exactly like the last part of that soccer punt lab that we started inside of the projectile shooter. Okay, so one thing we're not is all good. So what do we need to do to be all good? All x's, all y's. So we need to figure out the velocity in the x direction, the velocity in the y. This one's easy, it's 10 meters per second. The velocity in the x would be the cosine of that, which would be 17.2. 17.32, we do that with the SOHCAHTOA thing. Okay. So really now, if we look at this, we have our velocity in the x direction. Now we're looking for time. So we're going to need to use the y velocity to figure out the time. There's a couple different ways we could do this, but let's just say that for this problem, I want you guys to tell me how high it's going to go. First of all, because I might be shooting over something. Okay, so I want to first know how high this is going to go. So how do we do that? Well, we can say x equals v sub naught t plus 1/2 at squared, and we should be able to find that height, except we don't have the time, right? So I'm thinking, man, up here, my v in the y is going to be equal to 0, so maybe I can easily find the time first using this formula, knowing that this is going to cancel out. I'm going to get a negative v sub naught y divided by a, and that'll give me the time to the top. Do you agree with that? So like the soccer kicks, in the soccer kicks, this point right here was halfway, and we utilize that to find half the time, then we multiply it by 2 to figure out how long our x velocity is going. But this isn't halfway anymore. But this is the highest point in the trajectory. And if I'm looking for height, I'm going to try to clear a fence or something like that, then I need to know that. Okay, so in this case, it's 10, or negative 10 divided by negative 10. The time to get up there is 1 second. Okay? And so now, I can use this number of ways. My favorite way is to drop it. So I say my v sub naught is 0, and my final velocity is 10, which is valid. Because then it just becomes this, x equals 1/2 at squared, x equals, well, -5, realistically, except for I'm dropping it, you know, so it's going to be a little bit different, times 1 squared. X shows -5 here, but you have to keep in mind that I messed around with the problem. If I was up here and I dropped it, it would be a -5. Do you agree? But I just utilized that part of the physics and my knowledge of what's happening in the problem to use this zeroed out y velocity, so I have to make sure that I'm careful and I don't put in a -5, because it doesn't go -5 high. Okay, so what this shows us is if we hit the apex, if something is less than 5 meters high, we can get over the top of it. Right? So now the question is, we're still trying to figure out time here. And we could plug it into this equation if we wanted to. And I'll show you how to do that real quick. We could go x equals v sub naught t plus 1/2 at squared. X would be -20 from absolute beginning to absolute end, equals 10, well, yeah, 10t minus 5t squared. We could put that into your computer and get 2 roots for, you know, possible time answers. And that's fine. You can use the quadratic equation if you want. That works. But the other way we could do it is, well, we know that it took 1 second to get up here, right? That's 1 second. And we know that it's 5 meters high. So if we drop ourselves again from this point, what's our new displacement from that point going to be? -25 meters, right? Because we went 5 meters high, now we're going to drop all the way. Nice thing is we're still working with this, so we can just say again, x equals 1/2 at squared, because our drop v sub naught in the y direction is 0. So we can say that time is equal to the square root of 2x over little g, time for the second part of the fall, because we knew that it took 1 second to get up there, is 50, or -50, divided by -10. So the time to fall is the square root of 5. So these two times together are the total time. So 2.24 seconds plus 1 is 3.34 seconds. Put that in there, and we get 17.32 times 3.34, and we get our x displacement as 57.85 meters. Okay, thanks, Mitch. That's 3.24, which brings us to 56.12 meters. Thank you. So if you look at your notes then on Moodle, this is kind of another show of what I just explained to you on the board. So here's some notes, here's another problem. I go through kind of, you know, the plan. This would be kind of what we were talking about in the video. And I give you an example how to do that. And here's all your answers. I think I gave a little bit more in the examples, but here's another thing for you to look at. if you have questions about how to do your homework. Okay, hopefully this helps.